Earlier we have already seen this topic, the ways we can perform I/O, input output, how are we going to connect the devices to the CPU, and how are we going to transfer the data from I/O devices and CPU, in between I/O device and CPU. We have already seen this, but let's just go through it once, and again I'll get into the details here. Earlier, while I was discussing about the design of a normal computer, when we're talking about the simple computer, I discussed about it, but now I'll again tell you about the few points, and then we can get into the details here. So there are three ways we can perform I/O. The first one is programmed I/O, and the second one is interrupt driven I/O or interrupt initiated I/O, and the third one is DMA, right? And what is programmed I/O is, in every programmed I/O setting, CPU is supposed to execute a program, right? And every word, in order to move a word or some data from one register which is in the I/O, between I/O register and the CPU registers, we have to execute at least one instruction in case of programmed I/O. The problem with that is, if you are writing a programmed I/O, we have to have a program like this. See this. In this program, we are going to have three steps. First one is read the flags, read the status flag. So every device is going to have a status flag saying whether new data is available for transfer or not. Okay, and step 2 is, if data is not available. So how can we know that if data is not available? Status flag equal to 0, right? Status flag equal to 0. By checking this condition, if status flag is equal to 0, it means if data is not available, then go to step 1, right? And finally, in the third step, if you are coming to the third step, it means that data is available. If data is not available, you will go to the first step. You will keep on going to the first step, right? As long as data is not available, you will keep on reading the status, checking it, again go back, read the status, check it, go back, read the status, check it. You will be keeping on, you will be doing on this, right? So once you are coming to the third step, it means some data is available, right? Therefore we can write the instruction to move the data. This is what happens in a typical programmed I/O setting. Now if you observe this, clearly the disadvantage of this method is busy waiting. So what is busy waiting? We are going to have a flag, and as long as flag is 0, we keep on checking it, and whenever the flag turns 1, then we are going to transfer the data, and again we make it 0, right? So ultimately the disadvantage is processor's time is wasted, right? So most of our I/O devices, if you take a keyboard, maybe we will be providing data 1 character per second, right? So let us say you are providing a data at the rate of 1 character per second, right? Then the problem with this type of devices, if you are providing only 1 character per second, then you have to keep on executing these instructions. How many times? In 1 second, CPU, most of the CPUs have a capability to execute 1 million instructions, right? MIPS, 1 million instructions. Generally CPUs will be power will be given by MIPS, million instructions per second, right? So if you assume that instruction cycle takes 1 microsecond, which means in order to complete an average, if you assume that the instruction is going to take 1 microsecond to get completed, it means that in 1 second I could have executed 1 million instructions, right? Now instead of executing those 1 million instructions, I'll be stuck doing this, which means I'll be completely doing these 2 instructions for 1 second. So therefore this is obviously a disadvantage of this method. So no one is actually using this method currently. Earlier it was used. Right now we are not using it. So right now we have moved on to the next method, these two methods. So the next one is interrupt driven IO. The concept of interrupt driven IO is whenever there is a requirement or whenever the data is ready, our IO device is supposed to interrupt the normal program flow, and our CPU, it will then stop the normal execution of the program. Let us say it is the normal execution of the program is going on, then suddenly your IO device, whenever the data is ready, is supposed to interrupt you. At this point, CPU will stop executing the current program and it will go and execute the instruction, this interrupt service routine ISR, which will typically contain the instruction to move the data apart from some other things, and then you are supposed to come back and resume with your normal execution. So the advantage with this method is your program is not being stuck in a loop. You are simply executing a program, and whenever there is an interrupt, you are going back, and again you are coming back, and again you are resuming your execution. So the overhead is less compared to the programmed IO. In programmed IO, overhead is very high, right? So in fact you are not doing anything else. So efficiency of CPU is 0. The reason is it is not doing anything else, anything useful. But here if you look at this, yes, there is some overhead. The overhead is whenever there is an interrupt, you have to save the context of this program and then go there to the interrupt service routine and then see why the interrupt has occurred, and then take the required action and again store the context back. Therefore it is going to have some overhead, but the overhead is very less. It is not going to be 1 million instructions as in this case, isn't it? In this case, in order to move one character, you are actually wasting 1 million instructions, but ISR will not be 1 million instruction code. Therefore, even though for every character transfer, here also we are writing a program, but the program is not containing 1 million lines, right? So the overhead will be less in case of interrupt driven IO, right? So but then actually if you look at this the other way, interrupt is a facility not just provided to do the IO. We are using it in this context, but in general an interrupt is a signal which lets the CPU know that you have to stop the execution of the present program because something out of normal, which means some exceptional thing has happened, and so you have to stop the present program and service that particular and look at that scenario and then come back to the present program. So the main use of interrupt is to interrupt the current execution of the program, and it is not only used for IO, but in this context we are making it for IO. Let me tell you briefly about what are the various reasons we might get an interrupt in general. So if you are looking at the interrupt, there are various reasons we might get the interrupt. Sometimes it will be triggered by some sensors. So to tell you an example, let us say your program is executing something, your system is on and something is going on, and suddenly you are trying to hit the power button, press the power button and shut down the system. Then what happens is when you do this, when you suddenly when you are trying to turn off this computer all of a sudden, right, then the RAM, the status of the memory, it has to be saved in the hard disk. Otherwise later when you try to reboot it, you'll not be able to get your present work. So all the current work has to be saved, right? In that case, whenever you try to turn off the computer, there will be a trigger, there will be a sensor there. So your CPU will be triggered with this particular sensor, and it will say that someone is trying to switch off the power, or let us say you suddenly power is off suddenly because of the power cut or something, external disturbance, suddenly the power source is not giving you the power. Then suddenly this sensor will trigger the CPU, and within those microseconds, that gap before the system turns off completely, within those microseconds of time, your entire image has to be saved somewhere, right? So for that reason again we'll be using the interrupt. whatever program is going on, that program has to be stopped and the entire memory image has to be saved in the disk before our program could shut down, or at least you have to do certain things which will help you when you are rebooting the computer again, right? So that is why this sensors will trigger the interrupts. And one more example of a sensor is, and these are of highest priority, which means if at the same time if more than one interrupt happens, generally the sensor triggered interrupts will be given the highest priority. And the other one is sometimes not in the present computers, earlier computers, they used to generate a lot of heat, and in order to avoid the circuit getting burnt up, whenever the temperature rises above certain limit, there will be a thermometer and it will trigger a signal, right? And that is also a interrupt. And whenever that interrupt happens, your CPU is supposed to slow down and probably halt for certain amount of time, so that the temperature will cool down. So again, these sensors, whatever these will be given highest priority. When there are two or more interrupts, the interrupts which are triggered by these sensors will be given the highest priority. It is not a mandatory thing, but it is being followed as a convention, right? And then certain other things, sometimes the other thing like timers will also give you interrupts. So what is the main advantage of using a timer is for implementing some scheduling algorithms like round robin. So you don't want to have a particular program run forever. We want to allocate it some time slot, and once the time slot is over, we want to schedule the next process, right? So for that reason we are going to have a timer, and whenever a program is executing, our timer will give a hardware signal, and that signal will lead to context switching and then the process switching, right? So it also has to be given the highest priority. Generally the second highest priority will be given to this sensors and then timers, right? And then other reason why you can get the interrupts is because of some traps. So there are traps, means some programming errors. Your program is trying to do something, and because of which either the result is going to be corrupted, or something else which is unexpected is going to be affected. For example, if your program is trying to divide a number by 0, then you will never be able to divide a number by 0 and store infinity in a result, right? So that is one exception. Or your certain registers might overflow because of a multiplication or addition. Then these are all exceptional conditions, or some traps are even severe. Sometimes every process will be given certain amount of memory or certain range in the memory for its access. Now a process, while executing, it might try to access the memory which is not allocated to that, and because of this action the other process might get corrupted. So we don't want any process to execute or to get into the memory where it is not supposed to enter, right? That is called as trap. So whenever such things happen, we'll have a hardware trap, right? So software trap and hardware traps. Software trap is whenever you try to divide a number by 0. Hardware trap is whenever you try to access the memory which is not yours. Or sometimes you might get into a infinite loop, right? Then you might use up all the space allocated for the stack. So as you know, there is heap, stack, and then data, and all these areas in the process, right? So whenever you are overrunning the memory, then also it will lead to some trap. So whatever it is, there are traps possible, and because of these traps they will also generate the interrupts, and they will be given the third highest priority. So again, I am saying that it is not a fixed rule that you should always allocate the priorities like this. Priorities, they might keep on changing depending on how you want your system to behave. Some people may say that I want the traps to be given the highest priority. Whenever there is a trap, you want the operating system to take the control over your system, even if others are there. But then conventionally people are following this. And the last type of events which will trigger the interrupts are IO events, right? In case if you are using interrupt driven IO, then IO will also be responsible to create the interrupts. Therefore, interrupts as such is not an invention or is not only useful to deal with IO. We have all the other things for which interrupt will be generated, and based on what has caused the interrupt, right, our system has to analyze it and take the correct action. Got it? But then in this topic, in this discussion, we are not going to get into details of these things. They are not required for the syllabus. No one is going to ask you about this, but you are supposed to know about the IO type, this interrupt related to IO, because we have this interrupt driven IO in the syllabus. So coming to this interrupt driven IO, in a computer we don't have just one IO device. We'll have a lot of IO devices. For example, a hard disk is a IO device, right? A keyboard is IO device, a mouse is IO device, printer, monitor, all these are IO devices. Therefore, any of these device might give you the interrupt, and once you get the interrupt, first thing that you should be able to know is who has generated the interrupt. With all these devices possible, now there are various things you should be looking at here, right? So let's get to that point slowly. Now what I mean to say is, IO devices which can generate the interrupts are of various types. What are all the IO devices that can generate the interrupts is all the IO devices that are connected to your computer. So typically, then which one should be given highest priority? Let us say you are having 4 IO devices connected to your computer, and now there is an interrupt, there is an interrupt, and now when you checked it, there are interrupts are generated by more than one IO device. Which one do you want to service first? Which one do you want to satisfy first before you go to the next one? So that is also called as giving the priority, right, or priority interrupts. Now in general, we see the thing is simple. When do we get the interrupt? Whenever data is ready or the IO device is ready. Now let us say you have a keyboard which is in which someone is typing, and then you have a memory hard disk and it is transferring you some data. Which one is faster? Generally memory device, this hard disk is faster compared to the keyboard. So if you don't process the interrupt generated by hard disk, there is a chance that you might lose the data. Let us say there is a hard disk, and from hard disk it is transferring the data onto a IO controller or an IO interface, and from IO interface you are supposed to transfer the data into the main memory through CPU, right? Now if CPU does not respond immediately, there is a chance that our hard disk might overwrite the existing data. Therefore, the faster devices have to be serviced first. So if you are looking at the priority which has to be given to the IO devices, generally the fastest IO devices will be given the highest priority, right? So which means our hard disk will be given the highest priority, and after the hard disk, maybe if you have a mouse will be given the next highest priority compared to, see, it is all relative, right? Which one is faster, that is how we are going. So first the hard disk will be given and then the mouse will be given, because if you are just dragging a mouse, then what happens is the data generated by the mouse is going to be very fast, because you can drag a mouse from the top of the screen to the end of the screen and all those pixels have to be covered, right? Therefore the data that is required by a mouse has to be that is generated by the mouse is actually very huge. So after this hard disk, the speed of mouse is very high, and after mouse maybe printer. So a printer will be able to print the output very fast, right? Or maybe a scanner. A scanner will be able to read very fast. And then finally keyboard. Keyboard is generally the slowest device, because when we are typing, we will not be able to type more than probably 2-3 characters per second. So in that time, in 1 second, our CPU can execute 1 million instructions, right? And similarly, in 1 second, we can actually transfer in 1 microsecond a complete block of in 1 millisecond a complete block of data. Therefore, the data that is being transferred by these devices, so depending on the speed of them, we are going to give the highest priority. right? So if you don't consider all these things, if you are consider only the IO devices, then when you are having these many IO devices, we are going to go in the priority according to the speed. So in the exam, if they mention that speed of this device is so and so, the speed of this device is so and so, which one do you think will be given highest priority in the priority interrupts? Then the answer has to be the device which has the highest speed. Got it? Okay, now we shall get into details, some more details about the interrupts. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.